Okay, let's do some more examples for section 6.7, financial applications of exponential and logarithmic properties. So Bob wants to buy a car worth $25,000 in 3 years. How much should he invest now in an account compounded continuously at 7%? So this is our continuously compounded interest. That's the formula we're going to be using, which is A equals P times E to the power of R times T. So looking at what we are told, we know that he wants to buy a car worth $25,000 in 3 years. So at the end of it, he needs $25,000. So that's going to be the value at the end of our time period, which is 3 years. How much should he invest now? That's going to be our principal. That's what we don't know. In an account compounded continuously, that's how we know which formula to use at 7%. So our interest rate is 0.07. So we have to move that decimal point 2 places. So then we will have in our formula A, so 25,000 equals P, which we don't know, times E, which is just that number, 2.7. We'll use our calculator for that. Raised up to the power of R, so 0.07, times T, which is 3. So I can simplify that exponent, P times E to the, that would be 0.21. And then we'll just divide both sides by E to the 0.21. So the value, the exact value we'd have for P would be 25,000 divided by E to the 0.21. Of course, we're going to want a decimal approximation for that. So I'm going to use my calculator to do 25,000 divided by E to the power of 0.21. And that gives me $20,264.61. Remember that we round at the end, and when it's money, we're going to round to the nearest penny. If Bob decides not to buy the car, so he decides he's not going to buy that car, how many years until he has at least $150,000? So this is the same account, so it's still compound continuously at 7%. So we're still using that A equals PE to the RT. R was 0.07. So he decides not to buy the car. So we're going to assume that he has $25,000 and he wants to have at least $150,000. So just kind of moving on from that previous example, he is going to start with $25,000. So that's our principal. This is how much he wants to have at least. So that's our A, 150,000. And then times E to the 0.07. And we want to know T. T is what we don't know. Okay. So to start solving this, we would divide both sides by 25,000. And that's going to be 6 equals E to the 0.07 T. And this is a variables in exponent problem. Variables in exponent. So we want to isolate the base, which we just did by dividing by 25,000. Then we are going to take the natural log of both sides. So natural log of 6 equals natural log of E to the 0.07t. And the reason why we take the natural log of both sides is so we can bring that exponent down in front. So then we have natural log of 6 equals 0.07t times natural log of e. But remember that natural log of e is 1. So then to solve for t, we can divide both sides by 0.07. So the value for t, the exact value for t, is natural log of 6 divided by 0.07. And so that's going to be the exact amount of time before we have that $150,000. So if we do natural log of 6, enter, divide by 0.07, we would have approximately 25.59656385. But they want to know like how many years, like to the nearest year. So we're going to have to go up to 26 years. Now, an interesting thing about these problems, when they want to know how many years until we have at least a certain amount, this is what I was talking about in a previous problem. Even if this had been 25.01, if we only wait 25 years, we're not going to have at least 150,000. We would have slightly less than 150,000. So in this type of a problem where they ask you at least 150,000, you're going to have to round this up to the next year regardless of the decimals. Okay, effective rate of interest. That was a new formula. We have not used that one yet. And remember, there were two of them, one for compounded n times per year and one for compounded continuously. So this one is obviously going to be the one for compounded n times per year. That formula was R sub e, that's the effective rate of interest, that's what we're solving for, equals 1 plus r divided by n to the power of n minus 1. And then the compound continuously is R sub e equals e to the r minus 1. So let's work through these problems. We've got 6% compounded monthly. So we're trying to figure out what is R sub e. And we're going to go with 1 plus r, which would be 0.06, divided by n, which would be 12, up to the power of 12, and then subtract 1. So this is going to be just a matter of working things out in our calculator. So I would take, in my calculator, I would do 1 plus 0.06 divided by 12, and then enter. And then I would raise that to the power of 12, and then enter. And then I would subtract 1, and then enter. That's how I'm going to put that in my calculator. So 1 plus 0.06 divided by 12, enter, to the power of 12, enter, subtract 1, enter. So that gives me R sub e equals 0.0616778119. And the effective rate of interest is going to be an interest rate. So we will move our decimal 2 places to the right to turn it back into a percent. So we will have 6.17%, or whatever they ask you to round to in your percent. Same kind of story for compound continuously, just using a different formula. So R sub e would equal e to the r, which will be 0.06, and then subtract 1. This one is a lot more straightforward in the calculator and in writing it down. So we will just go e to the 0.06, and then make sure you get out of the exponent or hit enter, and then subtract 1. So we get R sub e would be 0.0618365465. So again, move your decimal place 2 places to the right to turn that back into a percent. And we would get 6.18% this time. Okay. Let's see what our next page has in store. What quarterly interest rate would be equivalent to an effective interest rate of 8%? So we're using the effective rate of interest. That's the formula we're wanting. And it's not compound continuously, so it's going to be this, the R sub E equals 1 plus R divided by N raised up to the power of N and then minus 1. So let's figure out what all of our numerical values are in here. We have got quarterly interest rate, so N is 4, and the effective interest rate, that's E sub R. So E sub R is 0.08, and they're wanting to know what is the quarterly interest rate. So this time we're solving for R equals. Okay. So our, well, that's not E sub R. Oh, y'all, it's R sub E. Okay, my bad. So the effective interest rate would be 0.08. So 0.08 equals, and then we've got 1 plus R, which we don't know, divided by N, which is 4, and then raised up to the power of 4, and then minus 1. So we're going to start this off by adding 1 to both sides. So we have 1.08 equals 1 plus R divided by 4 to the 4th power. Now we've got to try and get that R by itself. So we have to get it out from doing to the 4th power. So what we're going to do is we're going to take the 4th root of both sides, because the opposite operation, or the inverse operation of raising to the power of 4, is a 4th root. So then I'm just going to leave it exactly like that. 4th root of 1.08 equals, that's going to take this exponent off. So I have 1 plus R divided by 4. I'm going to run out of room. I have to start looking up here. So then I will subtract 1 from both sides. I'm going to move up here. So I have the 4th root of 1.08, subtract 1 equals R divided by 4. And then multiply both sides by 4. So I have 4 times 4th root of 1.08 minus 1 equals the quarterly interest rate. So I'm going to go to my calculator. And you might just need a reminder. I mean, I would probably need a reminder if I hadn't just looked at how to do this, about how to get to the 4th root. To get a 4th root, one way to do that is to do the number 4 and then the math button and then option 5. Okay. So that's what we're going to do here. I'm just going to put this in my calculator exactly how it appears. So I'm going to say 4 and then parenthesis. And then to get the 4th root, I do 4 math and then 5. And that gives me 4th root of 1.08. And then I have to arrow to the right to get out of the radical and do my subtract 1. And then close my parenthesis and enter. So I get R equals 0.0777061876. And since I need that answer to be a percent, I'm going to move over twice and round to whatever they ask me to round to in my answer. So I'll go with 7.77%. Okay. If the rate of inflation is 3%, what is the purchasing power of $20 in 2 years. So this formula that we're using is purchasing power. And that is A equals P times 1 minus R to the N. So let's figure out what they tell us and where it's going to go in the formula. Inflation rate is 3%. That's easy. That's R. So R is 0.03. And then we want to know what is the purchasing power of $20 in 2 years. So our T, well, it's not T in this formula, it's N. So our N is the number of years, is going to be 2. The purchasing power is P. So A is the amount that P dollars will purchase in a number of years. So the P is the $20. A is the purchasing power. It's how much are we going to be able to buy with my $20 that I have. So let's work through our formula. A is the thing we don't know. P is the $20 times 1 minus 0.03 to the power of 2. So 20 times 0.97 squared. So my money is only worth 97% of its original value, and that goes over 2 years, so that's why we are squaring it. So I'll go on my calculator, 20 times 0.97 squared, and that amount of money, I get 18.818, so $18.82. Okay, for the 2020-2021 school year, college algebra class, this is your last example that you will ever have to take of notes in this course. I know you're all applauding. I slightly am as well. It has been a crazy, crazy year. The purchasing power of $100 is $93 after 5 years. What is the average rate of inflation? Okay, so again, it's the purchasing power formula. So A equals P times 1 minus R to the N. Don't mind the squeaky, that's the puppy. So what do they give us in here? The purchasing power of $100 is $93. So the amount we're able to buy after 5 years is $93. So A is the amount that we're able to purchase with our original $100 after 5 years, which is N. And they want to know what is the average rate of inflation. That is R. We don't know. So we do 93 equals 100 times 1 minus R to the power of 5. To start solving, we are going to divide both sides by 100 so that we have our exponent situation by itself, which is where our variable is. So 93 divided by 100, that's 0.93, equals 1 minus R to the 5th. The inverse, or the inverse operation for raising something to the 5th power is taking the 5th root. So we'll take the 5th root of both sides. I'm just going to leave it like this. I just have the 5th root of 0.93 is going to equal 1 minus R. Then we will, not add 1, subtract 1 from both sides. So our value of negative R, I have to move up here again. Negative R is going to equal negative 1 plus the 5th root of 0.93. So R will equal 1 minus the 5th root of 0.93. So we just talked about how to find the fourth root, and we're going to do the fifth root the exact same way, except for we're going to use 5 math 5 instead of 4 math 5. So to do this in my calculator, I'm going to have 1 minus, I have to do 5 math, and then choice 5 is the fifth root, or the xth root. So 5 root 5 of 0.93, and we get r equals 0.01440936162. Again, we need to turn that into a percent. So go 2 decimal places to the right. And our average rate of inflation was 1.44% over that 5-year time period.